Hello and welcome to my channel. I am the Mad Computer Scientist. On this channel I discuss math, computer science, and technology topics that are of interest to me. If you are new to this channel, I would like you to do me a favor first. If you have not already done so, please hit the like button. Be sure to hit the subscribe button, and if you subscribe, be sure to ring that notification bell so you will always get the latest updates. And today we're going to cover the blockbuster sequel to the video Laws of Exponents that I promised. Now, a bit of background information: this video did get delayed. Not because I wanted it to be delayed, but because I saved this video somewhere and could not remember where I saved it. So I have redone the video, and now I am re-recording it, so you get to enjoy it. Because I know you have all been waiting for this video all summer, on the edge of your seat, let's go over what those laws are again. The laws are the log of a plus the log of b equals the log of a times b. The log of a minus the log of b equals the log of a divided by b so long as b does not equal 0. And I'm sure you all know why that is. And the log of b squared equals 2 times the log of b as long as b is greater than or equal to 0, because you cannot take the logarithms of negative numbers. All right, let's go on to the next step and see how we're going to use these laws to help us do math. Now let's talk about the first law. And by the way, these are just numbers I've decided at random. They're not actually in any specific order. This is the one where the log of a plus the log of b equals the log of a times b. Now I'm sure you're wondering, when am I ever going to use this in real life? Well, let's say you have a calculator with a logarithm key, and you don't want to use the multiplication key, or you have logarithm tables and no calculator available, which if you're older you may have had to do when calculating these problems in the past. So instead of hitting 63 times 83, you could hit log of 63, add the log of 83, and hit the inverse log key. You will get the same result that you would have gotten if you had hit 63 times 83. Now let us talk about the second law that we're going to cover for logarithms, which I believe says a robot must obey the orders it is given by a human so long as those orders do not contradict the first law. No, wait, that's Asimov's laws of robotics. Well, I never said the jokes on this channel were good, but at least I'm trying to put them in there now. So this law is that the log of a minus the log of b is equal to the log of a divided by b so long as b does not equal 0, and this is essentially a quick way to do division. So let's say we want to do 128 divided by 32. We just hit log of 128, then hit the subtract key, hit log of 32, and when we get the answer, we hit the inverse log key. And that will be the same result we would have gotten if we divided 128 by 32. Although the last two laws were very exciting, and I know you very much want a lot more laws in this video because it's exciting, there's only one left. We're going to talk about the third law that I presented in this video, which I'm pretty sure states that for every action, there is an equal and opposite reaction, or that might be the laws of motion. I think in this case, what I'm referring to is the law of logarithms that states the log of b squared is equal to 2 times the log of b. Now you're probably wondering how you're going to use this, and essentially we use this to solve algebraic equations with a variable as an exponent. For example, we have 5 to the x power equals 625. Now, I know a lot of you can probably do this in your head, but follow along with the steps, and if you're not really good at mental math like I am, check it at the end with a calculator to make sure your mental math is correct. So then we rewrite the equation as log 5 to the x equals log of 625. Essentially, we're taking the log to both sides, because in algebra, whatever we do to one side of the equation, we have to do to the other. Then we can rewrite it using the laws of exponents. So it is equal to x times the log of 5 is equal to log 625. Now in the next step, we're simply going to divide both sides by the log of 5. and we should get x equals 4, which I just checked on my calculator, and that is indeed correct. This is how you convert logs of one base to another base as well, by the way. Alright, that is it for this video, everyone. Please remember to like, comment, and subscribe. I'm sorry this video took so long to get out. I did intend to have it up sooner, but as I said at the beginning, I saved it somewhere else on the hard drive, and I have not been able to find where I saved it. I am sure I will find where I saved the original video right after I upload this version, which is shorter. But before we leave this video entirely, let's talk about the real-world applications of the laws of logarithms. They're useful for multiplying and dividing quickly, calculating interest rate problems, specifically continuous interest rate problems involving the number e, population growth rate formulas, which can also involve the number e, and this one may seem a little weird, they're also more than a little useful for understanding some XKCD strips, because that's just the type of humor XKCD has. With all that being said, go out and write some code, and we will get around to the bubble sort algorithm the next time we do one of our regular uploads.